Thank you guys for watching the previous video, and now I want us to learn about the Laplace transform of cos AT. But before we go to the Laplace transform of cos AT, please like, subscribe, and click the notification icon. God bless you. Yesterday we said that the Laplace transform of sine AT is a over a squared plus s squared. I hope you can remember that. So today we are going to deal with cos AT. When given a function known as cos AT as our function of time, we are going to look for the Laplace transform of cos AT today. So, as we said earlier, function of s is equals to the Laplace transform of ft, which is equals to integrating from 0 to infinity. Don't forget this, integrating from 0 to infinity. It is very, very important. E minus st, e exponential raised to negative st. You multiply by the function of time, which we are given as cos at. Then you differentiate with respect to time. So we can rewrite now Laplace transform of ft is equals to integrating from 0 to infinity e minus st, e raised to negative st, times cos at. Our cos at is the function of time. Then we differentiate with respect to time. So we come back here again. We say integration, the rule of integration by parts. Please don't forget this rule. Integration by parts. Very important rule for this case, for the case of Laplace transform. For the case of Laplace transform, we use integration by parts. And now we have this formula which says I is equals to uv minus integrating v du over dt dt. Says I is equals to u, a function of u, a function of v, u times v, minus integrating v du over dt. Then you differentiate with respect to time. So this is our integral. Now we have it. But now we can call it I1. So that because we will have an I2. And now we say now our u is this first part here. So I like to write first the I1 is equals to integrating e minus st cos at dt. So our u is equals to e minus st. And because in this formula of integrating integral 1, we have du over dt, we can also say du over dt is equals to, yesterday we said that it is negative se minus st. Hope you remember that. Then we have v is equals to, we don't have v in this place, but we can get v from dv over dt, which is equals to cos at. Very important, this is dv over dt, this one is u. So our v is gotten by v is equals to integrating dv over dt, which is equals to integrating cos at. And our cos at, when we integrate cos, we get sine. When we integrate cos, we get sine. And this value that is attached to t, it becomes a fraction, or we divide it by sine. Sine divided by the value attached to t, and it goes back, it remains to at still dt. So now we rewrite our I1 is equals to e minus st, this is our u, then uv, this one here, times 1 over a sine at. That is our uv now. Then you subtract the integral of integrating v, this one here, 1 over a sine at dt, times our du over dt minus se minus st. Okay, now we open the brackets. So this will be I1 will be equals to e over a. This is e power negative st sine at. You subtract, you combine, this is 1 over a, this is s. So negative times negative is positive. So this negative times this negative, you get a positive. And then you remove s and 1 over a. So it becomes s over a. Integrating e minus st dot sine at dt. Now we go. Integration by parts, where I was saying now we are going to I2. So I2 is equals to uv minus integrating v du over dt dt. Our u here in this case, so our I2 is equals to e minus st, that is integrating e minus st, e raised to minus st sine at dt. So now we come and integrate this. So our u here is equals to e minus st, as we had said previously that du over dt, we have to find du over dt because it is in part of this expression. So it is equals to negative se minus st raised to negative st. Then we find our v. Our v we don't have, but we can have, we have dv over dt, which is equals to sine at. So to get our v, we integrate dv over dt, which is equals to integrating sine at, which is equals to, when we integrate sine we get cos, and when we integrate sine that is attached to a value to t, it remains at there, but now this a becomes a negative 1 over a. It becomes a negative fraction of the value that is attached to t. And now we say, now we come down to combining the equation now. So I2 is equals to u is e minus st. You multiply by v, this one here, negative 1 over a cos at, subtract, integrating. We have our v again, negative 1 over a cos at. You multiply by our u du over dt, which is negative se minus st. So now we open the brackets. I2 will be equals to e minus st, that is negative is equals to negative e minus st. This is e over a, this a here, this negative is this one, cos at. You subtract. Now we remove this out of the bracket. Negative s times negative 1 over a, you get positive 1 over a. So this sign doesn't change, it remains because the negatives inside here have changed to positive. So this s over a. Then integrating e minus st cos at dt. But we say but here. We say but I1 is equals to integrating e minus st times cos at dt. And when we look at this expression here, it is this expression here. So we can change this one to I1. So we rewrite this. So I2 is equals to negative e minus st a cos at minus s over a. E, that is, now we change this part to become I1. Are we together until there? So after here now we come and write I2, I1. We go back to I1. I1 we had said is this one here up, e minus e over a minus st. sine at plus s over a. Remember, this one is what we integrated, so we open a box bracket for this case for I2, which is minus e minus st over a cos at minus s over a I1. Hope you are together until there. Cut. So, okay, now we need to open this bracket here. So we'll write I1 is equals to e minus st over a sine at plus. This will be s over a squared. A times a is a squared. This is e minus, which now this minus here, remember there is a subtraction sign here, will come here. So this one changes to negative. Hope we are together till there. So now we write e minus st cos at. You subtract. Plus times minus is minus. The same here, plus times minus is minus. So s times s is s squared. A times a is a squared. I1. We have already opened the bracket. So I1, we say is equals to e minus st over a sine at minus s over a squared minus, this is e minus st cos at minus s squared over a squared I1. So we bring this I1 to this side. So let us carry this I1 to this side. So I1 plus, when we cross from the negative, when a value is attached to negative value and brought across the is equal signs, it becomes positive. So it becomes a squared plus a squared over a squared I1, which is equals to our e minus st over a sine at minus s over a squared e minus st cos at. Now we need to replace the limits. So this is equals to e minus st over a sine. Now we need to put our limits at, that is 0 to infinity, minus s over a squared. Now this we do like this. We open our box bracket and we say e minus st cos at. We put our limits and we close the bracket. We need now to do e over a minus infinity, s infinity, sine a infinity. We subtract e minus s times 0 over a sine a times 0. That's how we express it, minus s over a squared e raised to negative s times 0. So negative s times 0 is 0. So e raised to 0 is 1. So cos 0, a times 0 is 0, cos 0 is 1. So 1 times 1 is 1. So now we put 1 outside there, inside there. And now we want to remove I1 outside the bracket. We say I1 is 1 plus s squared over a squared is equals to 0 minus 0 is 0. So minus s over a squared times minus 1. You get it's equal to s over a squared. This is minus times minus, you get positive. Now we come down here and say I1. We make a common denominator of a squared. A squared times divided by 1, you get a squared. Times 1 is a squared. Plus a squared divided by a squared is 1. Times a squared is s squared. This is equals to s over a squared. Okay, so I1, we want to remove this side and this value here, put this side. So we multiply by the reciprocal of this fraction, which is I1 times a squared over a squared plus s squared. You multiply by a squared plus s squared over a squared. So that becomes 1 times, this is a s over s squared. You multiply by this value here, a squared over a squared plus s squared. So this one and this one, they cancel and give you 1. So I1, our integral, we cancel here, a squared 1 by a squared 1. S times 1 is equals to s. Then you remember that there is s squared plus s squared. This now is our integral for Laplace transform for. So the Laplace transform of cos at is equals to s over a squared plus s squared. So if this a is equals to 3, which means that it is cos 3t, our Laplace transform for cos 3t will be s over 3 squared plus s squared, which is equals to s over 9 plus s squared. Please don't forget to subscribe, like the video, and click the notification bell. God bless you.